Okay, so this is your calendar for today. We're doing projectile motion. Pause this so that you can copy the calendar down because I'm about to switch over to the other screen. All right, this is going on page 135 when we're done. And there's going to be a lot of times on here that I'm going to ask you to pause the video to make sure you can type it in right. I'm going to keep going though because some of you may need longer to type things in if you type something wrong or whatever. So I'm just going to tell you to go ahead and pause and make sure you can get the answer yourself, or obviously you can pause and rewind at any point you need to. But I want to make sure you have enough time to actually type these things in and don't just copy down what I have. So we're still looking at parametric equations. They're often used to model projectile motion. So parametric equations, projectile motion. If an object is projected at an angle of elevation of theta, then the horizontal distance and vertical position of the object can be represented by the following parametric equations. Okay, so we have an x equals and a y equals. So we get x equals t times v sub 0 times the cosine of theta. And then y equals t times v sub 0 times the sine of theta minus 1/2 g times t squared plus h sub 0. So let's talk about those variables. T is time. Now remember, for parametric equations, t doesn't always have to equal time. It does with projectile motion though. V sub 0 is the initial velocity, or the initial speed. G is the gravitational constant. We're going to use two different ones. And then h sub 0 is the initial height. So the gravitational constant is the acceleration of the object due to gravity. At the surface of the Earth, this value is 9.8 meters per second squared, or 32 feet per second squared. So it depends on whether or not we're talking about feet or meters in these situations. So make sure you can use both of those. All right, so let's read example number 1. It says, Mark kicks a soccer ball upward from the ground with an initial velocity of 75 feet per second and an angle of elevation of 62 degrees. So let's think about some of the things that we are going to need. We need the initial velocity. That is 75 feet per second. I need the initial angle, or the angle of elevation, sorry. That is going to be 62 degrees. Then I need my gravitational constant, and since this is in feet, it is 32 feet per second squared. And then my initial height, well, since it says from the ground, that is going to be 0. All right, so it says make a diagram of the situation. Here's a quick little graph, right? We're starting at 0. He's going to kick the ball. It's going to look something like this. And then this would be 62 degrees. There's your diagram of what's happening with the ball. It says write the parametric equations to describe the horizontal and vertical position of the soccer ball at time t. So we're going to use this stuff here and these equations right here. So that means that x is going to be equal to t times v sub 0, which is 75, times the cosine of the angle, which is 62 degrees. And that's x. That's your equation. Then for y is going to be equal to t times 75 times the sine of theta minus 1/2 times 32 times t squared plus 0. That means that y equals t times 75 times the sine of theta minus 16 t squared. There's my equation for y. All right, so then we're supposed to find the horizontal distance the ball has traveled at 2 seconds. That means that t equals 2. Horizontal distance is going to be your x, so this is going to be x equals 2 times 75 times the cosine of 62. So make sure that your calculator is in degrees. If it's not in degrees, make that happen. If you're not sure, then you can just make sure it is and make sure it's on. You would hit Shift, Mode, and then 3 for degrees, and you should have the little tiny d up there at the top. All right, so then when you type it in, pause if you need to pause to type it in, and then x is equal to 70.421 feet. Then it says find the vertical position of the ball at 2 seconds. So again, t equals 2. Vertical position is going to be y. So y is equal to 2 times 75 times the sine of 62. Oh, I just realized I didn't put, this shouldn't be, I should have made that 62 and not just theta. Duh. Times the sine of 62 minus 16 times 2 squared. So pause and type that in your calculator. You should have gotten 68.442 feet. Let's look at number 2. We're going to make a diagram of the situation again, so let's read what's happening here. It says a tennis player serves a ball at an initial velocity of 35 meters per second. Ball leaves the racket at a height of 2 meters and an angle of elevation of 45 degrees. So our initial velocity is 35 meters per second. Our theta is 45. Our gravitational constant is 9.8 meters per second squared, because we're in meters now. And the initial height is equal to 2. So my little diagram here, this being x and this being y, when the tennis ball is hit, it's not on the ground. I'm not starting at 0. I got to start at 2 meters. So the ball is going to be hit and something like that. But then my angle has to go, remember, an angle of elevation has to go with the horizontal. This right here is my angle of 45 degrees. All right, so then I'm going to write the parametric equations to describe the horizontal and vertical position of the soccer ball at time t. That means that x is going to be equal to t times 35 times the cosine of 45. For y, y is equal to t times 35 times the sine of 45 minus 1/2 times 9.8 t squared plus 2. So y is equal to t times 35 times the sine of 45 minus 4.9 t squared plus 2. That's my equation. I want to find the horizontal distance at 1.5 seconds, so t equals 1.5. So the horizontal distance is going to be x equals 1.5 times 35 times the cosine of 45. Pause to get it in the calculator. 37.123 meters is what you should have gotten. If you didn't, then pause again and see if you can figure out how to get it right. Always try and get that right. Don't just copy down what I'm doing. Then I want to find the vertical position of the ball at 3 seconds, so t equals 3. So y equals 3 times 35 times the sine of 45 minus 4.9 times 3 squared plus 2. You can type that in all at once in your calculator. You get y equals 32.146 meters. Alrighty, on the back. So up here at the top, we're going to rewrite those basic equations so that we can look at them. X equals t times v sub 0 times the cosine of theta. And then y equals t times v sub 0 times the sine of theta minus 1/2 times g is t squared plus h sub 0. All right, so we have a football is kicked from the ground at a 45-degree angle of elevation. So we got a 45-degree angle of elevation, initial velocity of 60 feet per second. How long is the ball in the air? So it's kicked from the ground, right? So that means that this is our angle, this is our velocity. Our h sub 0 is 0, and our gravitational constant, since this is in feet per second, is 32 feet per second squared. So I want to know how long is it in the air. So in order for me to figure that out, I need to know, basically, I need the x version. Sorry, not the x version. I don't want the x version. That gives me horizontal. Y gives me vertical about talking about it in the air. So I'm going to write this equation. That's going to give me y equals t times 60, that's my initial velocity, times the sine of the angle, which is 60. Oh, no, it's not. It's 45. Dang it. Duh. It's 45. I already used the 60. So sine the angle, this is why we should write these things out. So my initial velocity is 60 feet per second. See, I was trying to skip steps. Not a good idea, especially not for me. 45 degrees. There we go. That makes more sense. 45 degrees minus 16t squared. So what it's asking me is not how high does it go after so many seconds. It's asking me how long is it in the air. It's asking me for the time, right? So I need to figure out what that time is. And in order for me to do that, basically I have to solve for t. So there's a few different ways I could do this, but this is a quadratic. This whole factoring and whatnot's not really going to work out for me. So I need to do the quadratic formula, which means I'm going to set this equal to 0. Okay, quadratic formula song. I put in the playlist separately so that you can go listen to that if you need to, but you need to know what it is. These aren't even in order. You can put them in order if you want to, but you need to make sure that you understand what A, B, and C are here. The A goes with the squared term. So here your A is equal to negative 16. The B goes with the t term here. So B is equal to 60 times the sine of 45. And then your C term is the constant, which we don't have because the initial height was 0, so C is 0. So let's think about what we do here. We do t equals, it's usually x equals negative b, but t equals negative b, so it's going to be negative 60 times the sine of 45, so that's your negative b, plus or minus the square root of b squared, so 60 times the sine of 45, minus 4 times a, which is negative 16, times c, which is 0. All over 2 times a, which is a negative 16. So if I clean this up a little bit, I'm going to get t equals negative 60 times the sine of 45 plus or minus the square root. Well, this is going to zero out all of that. 60 times the sine of 45 squared all over a negative 32. You could even make this just 60 times the sine of 45 because you're taking the square root, plus or minus is already there. You're going to have two answers. So when you type this in your calculator, you can type it in all at once. You obviously can't do plus and minus at the same time, but you could do negative 60 sine of 45 plus that, and then plus this one all over negative 32. I'd use the fraction button. It makes all of this very, very easy. You get an answer. And then you can arrow to the left and it'll take you back through this, and then you can just change that part right there to minus, and you don't have to type it all in again. So go ahead and pause, get your two answers, and then we'll see if we agree. Get t equals 0 and 2.651. Okay, so when it asks how long it's in the air, well, it starts on the ground at 0, at the time equals 0, and then this is when it hits the ground. So it's in the air 2.651 seconds, and we need to store this answer. So you have to make sure you actually get it. You can't type in 2.651 and hit store. You've got to actually calculate it and make sure you get this one. All right? Then store that answer somewhere, X, wherever you want it to store, because you're going to need it for B. So the B part says find the total horizontal distance the ball has traveled, right? Well, my horizontal equation is x equals t times 60 times the cosine of 45. So if I want to know how far it has traveled in the time it was in the air, I'm going to take this right here, t That's the t I found right here. That's why I want it stored, okay, because I can't type the decimal back in. And when you do this, you're going to get x equals, and it actually comes out prettier than you would think, because when you store it correctly, you're going to get 225 over 2, and we can just put 112.5 feet. Alrighty, number 4. The ball is caught by the player at home plate after 1.8 seconds. Oh, I should probably read the question first. A baseball player in the outfield throws a ball towards home plate. The ball leaves his hand at a height of 6.5 feet. Okay, so that's h sub 0 equals 6.5 feet. An initial velocity, v sub 0, equals 110 feet per second. That means my gravitational constant is, since it's in feet, it's going to be 32 feet per second squared. And that's all I have, right? They didn't give me the angle here. So let's read this question here. It says, the ball is caught by the player at home plate after 1.8 seconds. If the ball traveled a horizontal distance of 191 feet, find the angle of elevation at which the ball was thrown. Okay? So we know it traveled well, actually, let's write this equation down first. We have got x, because I'm talking horizontal distance, x is equal to t times the initial velocity, which is 110, times the cosine of theta, which we don't know. To find theta, we do know that it has traveled a distance of 191 feet. That is the horizontal distance. That is x. So that's going to equal, and in that amount of time, or in that distance, it was 1.8 seconds. 1.8 times 110 times the cosine of theta. Right. So if I multiply these two together, I'm going to get 191 equals 198 times the cosine of theta. That means that cosine theta is equal to 191 over 198. So I take the cosine inverse. Theta is equal to the cosine inverse of 191 over 198. So that means I get that theta is equal to 15.281 degrees. And then store that answer because you're going to need it. B says, what was the height of the ball when it was caught by the player at home plate? All right, so I need my y equation. So y is going to be equal to t times 110 times the sine of theta, which we have, but we'll leave it like that for right now, minus 16t squared plus 6.5. Okay. So when it was caught at home plate, the time was 1.8 seconds. Y is equal to 1.8 times 110 times the sine, I'm still going to leave this as theta, minus 16t, not t squared anymore, 16 times 1.8 squared plus 6.5. So I'm going to type all of this into my calculator once, but theta is coming from here. So wherever you stored it in x or whatever it was, you type all that in the correct order and do all of that right. Pause and make that happen. You should get y equals 6.842 feet. All right, example 5. A projectile is fired from the top of a 24-meter tall building, so our initial height is 24 meters. At an angle of elevation of 28 degrees, theta equals 28. Initial speed is equal to 55 meters per second. So our gravitational constant is going to have to be the 9.8 meters per second squared. So we are looking for the maximum vertical height reached by the projectile. So in order for us to figure that out, we have to have the y equation. So we're going to get y equals t times the initial velocity of 55 times the sine of the angle, which is 28 degrees, minus half of the gravitational constant. So half of 9.8 is 4.9. I'm just going to go ahead and write that down instead, times t squared plus 24. So maximum height. I want you to think about how you found the maximum with quadratics in Algebra 2. Because this is a quadratic, it's not in descending order, but that doesn't really matter. We should still be able to figure out what A, B, and C are. So do you remember your maximum being maximum is equal to negative B over 2A, right? So our B, this is our B, so we get negative B, negative 55 times the sine of 28 over 2 times a negative 4.9. So I need to know what this is, and I'm going to type all that in so we get that, and you can pause and make that happen. T is equal to 2.635 seconds, right? Store that number. It's not asking us for the, and it's not asking us when. That's when it hit the maximum height. That's why you have to know that that's actually the seconds. But this is important because then you're going to take this and you are going to substitute it in here. And if you store this number in your calculator, then you just type all that in using whatever variable you stored it in. So do that and get your y value. You would get that y equals 58.016 meters. That is the maximum height that it reached. Store that number just in case. Never know if you're going to need it or not, so keep it just in case. So we've got both of those. So then it says find the horizontal distance traveled by the projectile at the time it reached the maximum height. So I need my x equation now. X is equal to t times 55 times the cosine of 28. So here I need to use t, not y. Maybe I don't need that one. We'll see here in just a second. So I type all that in, pause if you need to make that happen, and you should get x is equal to 76.757 meters. All right, then it says, if the projectile is fired toward a taller building that is 300 meters away, will the projectile hit the building? If not, how far from the building will it land? All right. So here's what's going on here. We've got a building, right? Here's the building. Here's a taller building, right? So this projectile is shot, and it's going to go. It's either going to go here and like hit the building, or maybe it goes here and it hits the ground first. Like, we don't know, right? But this is 300 meters away. So what we want to know is whether or not it's going to hit the building. So therefore, I need to know when is it going to land. If I can figure out when it lands, like at what time it lands, then I can figure out how far it's actually going to go, like the maximum horizontal distance or even the maximum height. So let's write this out. In order to do that, I need my y equals equation. So y is equal to t times 55 times the sine of 28 minus, and then that's going to be that, oh, I already have it up there. We already did it in A, so I'm just rewriting it. Minus 4.9 t squared plus 24. Okay, so we already had the equation. But what I need to know is the maximum, oh, I don't need to know the maximum height here. I need to know when so it starts at 0 is the time. I need to know what time it lands, which means I'm not looking for a maximum here. I got to find the zeros, which means, again, I need to solve this. So basically, I'm doing quadratic formula. So t equals negative b, this is the b, negative 55 times the sine of 28 plus or minus the square root of b squared, 55 times the sine of 28 squared, minus 4 times a, which is a negative 4.9, times c, which is 24. So this time that doesn't zero out. all over 2 times negative 4.9. Type that all in the calculator just like you see it. Use that fraction button, but remember here you can only do one at a time. So do the plus and do the minus. Find the two answers. Okay, you don't have to retype it. You can always just arrow back. Pause and do that. Find your two numbers. I got that t is equal to negative 0.086 and 6.076. So those are the two things that I have. I don't want the negative. That doesn't make any sense, really. And then this is the maximum time. That's how long it took before it hit the ground, or before it would hit the ground. So we'll see how that matches up to this 300 meters. Because it says, will the projectile hit the building? If not, how far from the building will it land? So I need the horizontal distance, which means I need my x equation. So x is equal to t times 55 times the cosine of 28. Then I substitute in my stored number into there, and I will get that x is equal to 295.0 blah, 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 right? So that's how far it's going to go before it hits the ground. So if the building is 300 meters away, the answer is no, it will not hit the building. But 295 is not my answer. It says how far from the building will it land. So I need to subtract that from 300 and then say projectile will not hit the building. It lands 4.950 meters away. There you go. So as soon as you have this done, you can come ask me any questions that you may have and get your assignment and get started.